Hello, this is the Metrics. In today's video, we proud members of the Metrics would love to teach you, our dear viewers, simplifying trigonometric identities. Me, Alyssa Gaylle Lumaban, and my good friend Ralph Toldican will be helping me to teach you about it. Let's get started, shall we? Before we start breaking down the examples, we should first start off by knowing the terms and if the trigonometric identities it falls over. Let's first understand the terms. This circle-like sign means theta, sec, sec means second, sin means sine, and tangent mean oh my god. Tangent is tan, cotangent is cot, CSC is cosecant, and cos is cosine. By knowing all these terms, we can simply read this as second secant theta, sin theta, sin theta, tangent theta, cotangent theta, cosecant theta, and cosine theta. Now that now that we can read these terms, next thing we need to know is the identities. These are reciprocal identities, quotient identities, and Pythagorean identities. Right now, in the slide, it shows all the criteria where if the equation falls under each of those identities. For example, this tangent theta. By using the chart on the slide, we can identify that tangent theta it as a quotient identities. With knowing how to identify its identities is a key skill in simplifying trigonometric identities. We here at we here at the Metrics wants you, our dear viewer, to obtain that skill. We are going to provide 3 examples in this session that hopefully that can help you understand. Now that you are familiar with the identities, let's jump in. Let's start off at secant theta. By looking at the chart, we can say we can identify its reciprocal identities by basing it their secant theta is equal to 1 over cosine theta. With this, we can change secant theta to 1 over cosine theta. For cosine theta, we leave it as it is but we make it into a fraction as it's equal making cosine theta the numerator and 1 as the denominator. Now, when you have them listed out, we can cancel the like terms. With can with canceling with canceling of cosine theta, we are left with 1, making the final answer 1.
Here's here's the second example with the same logic. We have secant theta, sin theta, and cosine theta. With secant theta, it falls under reciprocal identities, while secant theta is equal to 1 over cosine theta. We can leave sin theta, leaving it as the numerator and 1 as the denominator, with same with cosine theta. With this setup, we can cancel out both cosine theta and leave sin theta with all the ones in equation, leaving the final answer to be sin theta. And finally, the last example, which is a little complex, but if you take in the other example to heart, it will have understood. With this equation, we should simplify it one by one. So we are going to simplify tangent theta and over secant theta. Tangent theta is in quotient identities, while secant theta falls in reciprocal identities. We will simplify them both first by doing the same method we showed you. When solved, when solved, take in secant squared, sin squared theta in mind. Now we solve the second part. Cotangent theta above cosecant theta. Cotangent theta falls into quotient identities while cosecant falls in reciprocal. By applying the same method we did earlier at the first part, such as cancelling the like terms, we are able to get cosine theta. Now we both solved two terms and we got sin squared theta and cosine squared theta. By looking at these two terms and we look at the chart of identities, it undergoes Pythagorean identities, making it sin squared theta plus cosine squared theta equals to 1, the final answer. Now, that wraps our video and we hope that it was useful for you all, my dear viewers. Always keep in mind that you can do it anything as long as you don't give up and put your mind and focus into it. Don't forget to leave a like and subscribe because that will help us this channel a lot. And we will see you next time. Bye. Sheesh.